Hello everyone, this is Charita. Welcome back to my YouTube channel. In this video, I'm going to talk about lexical analysis from the subject automata theory and compiler design. Now let's get into the topic lexical analysis. Lexical analysis is the first phase of the compiler, also known as a scanner. It converts the high-level input program into a sequence of tokens. Lexical analysis can be implemented with the deterministic finite automata. The output is a sequence of tokens that is sent to the parser for syntax analysis. Here is the diagram for the lexical analysis. Here, the input lexical analysis and the syntax analysis will be connected. From the input, the read characters will be passed into the lexical analysis, and the lexicon and the read characters will be converted in the lexical analysis, and it will be passed. It will pass the tokens to the syntax analysis, and syntax analysis will ask for the tokens, and then the analysis will push back extra characters to the input. This is about the schematic representation of the lexical analysis. Next, theory of computation. Automata theory, also known as theory of computation, is the theoretical branch of computer science and mathematics, which mainly deals with the logic of computation with respect to simple machines referred to as automata. Automata enable scientists to understand how machines compute the functions and solve problems. The main motivation behind developing automata theory was to develop methods to describe and analyze the dynamic behavior of discrete systems. Automata originated from the word automaton, which is closely related to automation. Next, tokens. A lexical token is a sequence of characters that can be treated as a unit of grammar of the programming language. Example of tokens, type of tokens, that is in the form of ID, number, or real, and punctuation tokens, that is if, void, written. Then alphabetic tokens, that is in the form of keywords. Example of non-tokens are elements, preprocessor directives, macros, blanks, tabs, new line, and etc. This is about the tokens. Next, how lexical analyzer works. First one, input preprocessing. This stage involves cleaning up the input text and preparing it for lexical analysis. This may include removing commands, white space, and other non-essential characters from the input text. Next one, tokenization. This is the process of breaking the input text into a sequence of tokens. This is usually done by matching the characters in the input text against a set of patterns or regular expressions that define the different type of tokens. Token classification. In this stage, the lexical determines the type of each token. For example, in a programming language, the lexical might classify keywords, identifiers, operators, and punctuation symbols as separate token types. Next, token validation. In this stage, the lexer checks that each token is valid according to the rules of the programming language. For example, it might check that a variable name is a valid identifier or that an operator has the correct syntax. Output generation. In this final stage, the lexer generates the output of the lexical analysis process, which is typically a list of tokens. This list of tokens can then be passed to the next stage of compilation or interpretation. Here you can see how the lexical analysis work from start stage to the end stage. Here they have given the start to the none, and then the other end of the line, and these are the compounds which is present in the lexical analysis. Conversion of the lexical analysis. Next, syntax analysis. When an input string, source code or a program is some language, is given to a compiler, the compiler processes it in several phases, starting from the lexical analysis, scans the input and divides it into tokens to target a code generation. Syntax analysis or parsing is the second phase, that is, after lexical analysis. It checks the it checks the syntactical structure of the given input, whether the given input is in the correct syntax, that is, of the language in which the input has been written or not. It does so by building a data structure called a parse tree or syntax tree. The parse tree is constructed by using the predefined grammar of the language and the input string. If the given input string can be produced with the help of the syntax tree, that is, in the derivation process, the input string is found to be in the correct syntax. If not, the error is reported by the syntax analyzer. Next, static scoping and dynamic scoping. The scope of a variable uh, x in the region of the program in which the use of x refers to its declaration. One of the basic reasons for scoping is to keep variables in different parts of the program distinct from one another. Since there are only a small number of short variable names and programmers share habits about naming of variables. Example, I for an array index. In any program of moderate size, the same variable name will be used in multiple different scopes. Scoping is generally divided into two classes, that is static scoping and dynamic scoping. Next is linker. Linker is a program in a system which helps to link object modules of a program into a single object file. It performs the process of linking. Linkers are also called as link editors. Linking is the process of collecting and maintaining the piece of code and data into a single file. Linker also links a particular module into system library. It takes object modules from assembler as input and forms the executable file as output of the loader. Linking is performed at both compile time when the source code is translated into machine code and load time. When the program is loaded into a memory by the loader, linker is performed at the last step in compiling a program. Here you can see how the linker works from source code to compiler, from compiler to assembler, and next object code, next linker, executable file, and loader. This is about the linker. And thank you for watching. Please do like